So the last piece we need to cover here on variation, standard deviation, all that would be this type of problem. And you see here it says when rolling 40 dice, we could think of it as rolling 40 different dice simultaneously, or one die 40 times. Same problem. What is the expected value, variation, and standard deviation of the number of twos that will be rolled? All right, I just picked twos just so I had something to talk about. You could really pick anything. But what hopefully you recognize is that this situation is a binomial situation. This can be defined as a Bernoulli trial. We can define this as success and failure. So I will define success, which Bernoulli defines as P, as rolling a 2. So therefore, the probability of success, the probability of this attempt being successful, no, that's not what I want to write. I'll just write it out. Probability of success, well, it's just rolling a die, and one of the faces has a 2, so therefore it'd be 1/6. So therefore, the probability of failure would be 5/6. So now you could try to go through a whole bunch of work to get your information here, but what Bernoulli says is the expected value is really easy. It's just n times p. How many times you roll the dice times the probability of success will give you what you expect to happen. And it makes a lot of sense. If you see here, we're rolling one die 40 times. 1 out of 6 of the rolls should be a 2. So therefore, 1/6 of 40 works out to be 6.6 repeating. So therefore, you expect about 6 2/3 of the time of the dice will be a 2. So you expect somewhere around 6 to 7 of the dice to be a 2. So therefore, now here comes the fun part. We've got the expected value. That was easy. How about variation? Well, variation is actually not much more difficult. It's just n times p times q. So therefore, variation, great. Standard deviation, well, this all still holds true. It's the same as everything before. It's just the square root of the variation. So there you go. I hope that helps. I hope that makes life a little easier. So you have to recognize when you can use this. That's the hardest part. And so remember, what we're looking for is something that's binomial, something that can be defined as success or failure, and the probabilities do not change as you roll the first die. The second die, the probability does not change. If the first die is a 2, does that make the second die any less likely to be a 2 or more likely to be a 2? No. So it's binomial. Okay, I hope that helps through some of your work.